Hello, everybody. I'm Robert Douglas. It's Friday, and this is Deploy Friday. We're going to be talking today about WebAssembly, or WASM, W-A-S-M, and this is the application runtime that is everywhere, fast, portable, and secure, and you are probably using it. You just might not already know it, but you're definitely going to hear a lot about it in the coming years because this is a technology that it's making its way into all sorts of spaces, starting with the browser, but certainly not limited to the browser. And today we have guests from around the world who are going to talk to us and inform us about this exciting new technology. So with that, let's get right into it and introduce our guests. I've got with me from a company called StackBlitz, we've got Kevin Hoffman and Sam Verschueren. And then from a company called WASM Cloud, I've got Kevin Hoffman here with me. So let's introduce everybody one by one. Let's start with you, Kevin. Who are you? Where are you? What's your connection to this technology?
My name is Kevin Hoffman. I've been using and playing with WebAssembly for a couple of years now. I wrote a book called Programming WebAssembly with Rust. And I'm also a creator and maintainer of an open source project that's built on top of WebAssembly called WASM Cloud.
Yep, let me get that link up there. WASM Cloud right there. That's a name that if I had said WASM Cloud to you 10 years ago, you would have probably crossed the street to get away from me. Right? I mean, that's it's kind of cool, WASM. I like it, but it's not exactly Google or Yahoo, right? WASM Cloud.
Give it time. It'll get there.
Give it time, right? It'll be a household word. Yeah. Honey, how's the WASM? All right, let's move on to you guys. The StackBlitz contingent. Sam, you want to start?
Yeah, sure. My name is Sam. I'm not going to pronounce my last name in English because it's not you can't.
Give us the full Flemish version.
Okay, Sam Verschueren.
Okay.
That's that.
Podcast editors, that wasn't a mistake. Don't edit that out. That was an actual word. Okay, thank you, Sam. So that already answers the question, where are you?
Yeah, I live in Bruges in Belgium. I joined StackBlitz recently, and I work closely together with Dominic on the new product that StackBlitz launched, being web containers. And web containers use WebAssembly under the hood quite extensively. So that's how I got in touch with the technology.
Fantastic. Dominic, who are you? Where are you? And fill out that story for us about the technologies that StackBlitz is using.
So my name is Dominic. I'm from Germany, and I live in the south part in Bavaria, which is close to the Alps. So it's very beautiful, and I often go on long bike rides. I really love that. And I essentially, similar to Sam, work with WebAssembly because of the work we do for StackBlitz for our product called Web Container. And yeah, that's basically when I fall in love with the technology. And it's very, very exciting.
All right, good. Thank you. Now, let's get to the important stuff. WebAssembly, what is it? Who wants to take a crack?
I can try. So I really like to think about web. So I think, by the way, there's an echo somewhere. I don't know where it's coming from.
Everyone on mute unless you're talking.
Aha! Now it's gone. I'm sorry. Didn't mean to squeeze that in. So I think when you talk about WebAssembly, you also have to talk about ASM.js, and I think because WebAssembly was highly inspired by ASM.js, and the idea behind ASM.js is basically to compile languages such as C or C++ to JavaScript to run on the web. But it's not just JavaScript. The idea was to, not just run that on the web, but also run that very efficiently. And so WebAssembly really is a binary format, and it's a compilation target, and it really takes this idea to the next level, because, well, as I said, it's a compilation target. So basically, other languages such as C or C++ or Rust, which is my favorite one actually, are being compiled to WebAssembly, which then runs on the web. And so it's a web technology. And, in this case, actually the host where that WebAssembly would be executed is in the browser. And because it's compiled, it does a much better job at being much more efficient when it's being executed than what ASM.js could do.
All right, so let me recapitulate what I heard there. What I heard is that you're compiling code that can be written in different languages into a binary that can be run in a predefined space. And in some cases, that predefined space is the browser. Is that a basic understanding? Kevin, am I getting that part of it right? Was there anything wrong in what I just said? I'm sure the picture is bigger than that as well.
No, I think the picture is bigger than the browser. WebAssembly, just because it's called WebAssembly, doesn't limit the technology to running just on the web. I think while it has origins in the web, and as Dominic said, it came from ASM.js. There's a lot of people, myself included, that are using WebAssembly purely on the cloud, on the server side. And all of the things that you get from running it in the web, the small size, the portability, the security, the efficiency, all of those things are things that we want on the cloud and in server side as well. So I think it's it does WebAssembly a disservice to treat it as just a purely web technology.
Is it a container? Should I think of it as a different type of Docker?
I think of WebAssembly as almost like the next evolution of Docker. If you think about the history of starting on bare metal machines and then going to data centers and then virtual machines and then Docker, the size of the container where our compute runs is getting smaller and smaller. And so it gets even smaller with WebAssembly. And so while the ecosystem isn't quite there yet, just because of WebAssembly's youth, I think WebAssembly definitely has the potential to be an evolution of Docker.
But with Docker, I would do things like package a MySQL database into the container. You wouldn't do anything like that with WebAssembly, to be clear, right?
No, WebAssembly, you want to package your compute inside the virtual machine.
Right. So it's purely for compute power.
Mm-hmm.
All right. Let's go around the room. Sam, I'd like to actually ask you first, what's your background? So you came to StackBlitz, and that's where you met WebAssembly. What was your background coming into that? What kind of profile of engineer are you that you got chosen to work on this?
My background mainly was I was mainly a backend engineer, so I used AWS extensively in my previous job, and I mainly used AWS technology to develop backend systems, but I never really came in touch with WebAssembly, or not like on the job. We didn't use it like to run certain compute loads, and I had a great background in like open source as well, and that's actually how I came into StackBlitz through all my work there, and then I worked closely together with Dominic, which was already working on big parts of Web Container, and that's how I came in touch with WebAssembly. It was not.
Go ahead.
Yeah, I wasn't like joining StackBlitz purely to work on WebAssembly stuff. It was more that I got involved through the things that I had to do.
So when you answer the question from your background, what is WebAssembly? How do you describe it?
Okay, WebAssembly, in my opinion, or from my view, is, like already said by others, it's a compilation target. So you can actually take something that already like runs natively on a desktop machine. For example, let's go with FFmpeg, which is a library which can compress audio and do a lot of video processing. You can take that, compile it to WebAssembly, and basically bring it to the browser, which is originally written in C++, but because of WebAssembly, that technology allows you to actually bring it to the browser, or to Node.js, for instance. It's not only the browser Node.js, but like Kevin already pointed out, you can also bring it to the backend environment. So,
all right, so I'm going to take a crack at this too, because of course I've been reading about this technology in preparation for the episode, and what I noticed when thinking about it is that when I think about the evolution of the web in particular, the early days of the web were quite exciting because browsers would basically load anything and run it. Well, I want to write a program in Java? Go ahead. You can write an entire program in Java and load it up into the browser, and it's a Java applet. And some of the early web applications that I worked on depended on Java applets to do amazing things, but you never see those anymore. And Adobe Flash created amazing web-based experiences that took forever to load and were always out of date, and made you, for some reason, also download Acrobat Reader randomly, but who knows why. But all those things are gone, right? Like Flash is not a thing anymore, and Java applets are not a thing anymore. And while Ajax and then Await and the rise of JavaScript frameworks inside of the browser have made things like Google Mail possible, and a lot of really amazing browser experiences, there's still this like upper level of compute intensive stuff like heavy graphics based programs, or stuff I don't even know all the possible examples. Anything that needs real speed and compute power is not really suitable for a pure browser-based environment in a lot of cases. And I think from what I understood, the main impetus for creating WebAssembly was to come to a secure, portable standard for running compiled code that isn't JavaScript in the browser, but that once you've got this standard for running compiled code in different settings and APIs around that to support that, then there are other benefits, like Kevin is pointing out, to running those in other environments. And from what I understand you guys are doing with StackBlitz, you guys are now moving environments that you see on the server normally, like a node environment, into the WebAssembly container and doing stuff with that. We're going to get to all of that. I'm fascinated and curious, but I would like to ask first, where would somebody have used WebAssembly now if they might not have known it? Who wants to go? I'll name some sites. I know a couple.
Okay.
Figma's very popular.
Sorry, can you rename? Can you repeat the question, please?
Where would somebody have used WebAssembly without particularly having known it, right? Like you might have already touched this technology and not knowing it. I'll name another one. Shopify. If you've done e-commerce and outside of Amazon, then chances are you've touched a Shopify site recently. They run so many e-commerce sites, and they use WebAssembly to speed things up, their page rendering engine, which was interesting. So Figma, Google Earth is another one. Who else? What else? StackBlitz.
Yeah, I just wanted to say, StackBlitz obviously now with Web Container, but I think there's also other examples. Maybe not always like directly consumer facing, or at least not directly always something that my mom would be using, for instance. Someone at Mozilla actually figured out and rewrote the source maps parser, which is also used for like the Mozilla's DevTools. So that one has been rewritten actually in Rust and compiled to WebAssembly, which, by the way, is also used by many other open source libraries such as Webpack, which, and Next.js. They all leverage that package, which is really used quite frequently. That's, I think, a good example. The WordPress Gutenberg parser for the Gutenberg format has already is also using WebAssembly. Or another one is like the Autodesk, the CAD program, which, they have this CAD program, which they've been working on for so many years. I think, I actually don't know for how long, but it probably at least 30 years. Like, it's a super, super old system already. And that is now being compiled to WebAssembly, so you can use that CAD program on the web, which I think is fantastic. And other companies like Dropbox, for instance, contribute to the research of compression algorithms, because for a company like Dropbox, size, or at least the amount of data they have to store, is so massive, and even like small numbers of improvement, like even if it's just 1% of improvement in like the size they have to store on disk, makes a big difference. And
yeah, there was a TV show about that, about the compression algorithms and startups.
Yeah, and so for them it's like very essential. And so what they've done is there is already compression algorithms, like you can use zlib, for instance, or other, but they've contributed with, like, it's called, what is it called, diff what was that, diff ans, something like that. Anyways, there's a compression algorithm which they've worked on, and that can be compiled to WebAssembly, and it can be used on the web as well.
So
and other
let
platforms.
me ask if I understand what that means. So compression algorithms, super important to minimizing costs and speeding things up. Generally
Correct.
universal to everything, like Netflix, everything. And you're saying that this complex compute-intensive thing can be compiled into a WebAssembly so that it could run in the browser or on a server or any place else.
Yeah.
And that it's portable and secure and near native performance. So those are the benefits. Why is it secure?
Correct.
Why do people say WebAssembly is a secure environment? Kevin, I see you coming off mute. Go ahead.
Yeah, I can take a stab at it. There's a number of reasons why it's considered secure, or more secure than some of its predecessors, but most of it has to do with the instruction set. As you know, WebAssembly is a virtual machine, and so there's a limited set of instructions that you can run in that machine. But unlike regular assembly that has operating system level control, WebAssembly doesn't. It just has pure compute instructions, so it can't do anything natively in its own instruction set that isn't either pure compute or a capability that's granted to it by the host. So on its own, it's able to execute functions, but it can't reach outside its own sandbox. And so the combination of its limited instruction set and the secure linear memory that WebAssembly uses means that WebAssembly on its own, or WebAssembly modules, are secure by nature. And they only get less secure by you giving them more and more powers. So there's a standard called WASI, or the WebAssembly System Interface, and that gives WebAssembly modules some limited subset of operating system functionality, so they can read files. But again, those are only capabilities that are granted to the module by the host. If the host doesn't want to give it that power, it doesn't have to, and there's nothing the module can do to take it.
Okay, that makes sense. Is that limiting as a programmer? Are there use cases where WebAssembly wouldn't be a good fit because of that? Help me understand the borders and boundaries.
So it could be limiting as a programmer. So there are things that you just can't compile into WebAssembly because they can't be represented as that subset of instructions.
For example?
But well, so for example, one of the things that you see a lot with WebAssembly is people say that this amazing game was recompiled into WebAssembly, and you can now do all these sorts of great things with. You can play these games in WebAssembly, but what people aren't mentioning is that WebAssembly has no I/O. There are no I/O instructions in WebAssembly other than interacting with its own memory. So all of these games that you're playing in WebAssembly, the host is taking care of the I/O. The host is taking care of the graphics driving and all of the interaction with whatever screen you're using. And so the host could take that ability away at any time. So, Unity is a good example where you can compile your game in and run it on Windows natively or run it inside a browser through WebAssembly. But what's not talked about is there's a whole extra set of shim code that comes along with it that WebAssembly can't represent on its own. So you often see it shipped alongside a big pile of JavaScript that takes care of working with the HTML5 canvas.
Okay, I was going to ask if the screen rendering then is done through Canvas, and there you go. So it is. So if WebAssembly can't actually run the canvas, what is it good for? Is it like vector analysis and stuff like that? 3D rendering algorithms? What does Unity do with that then if it can't actually render the canvas?
So I'm not sure of all the low-level details of what Unity is doing, but in general, what you see is the functional compute is what gets compiled into WebAssembly, and then all of the side effects and the I/O, those are the things that are taken care of outside of the WebAssembly module. And no matter what you're doing, whether you're talking about talking to a terminal or an HTML canvas or a database in a cloud server, somebody has to agree on a protocol for that WebAssembly module to talk to the outside world. So in the open source project that I have, that protocol involves consuming cloud capabilities, but a similar protocol would just be, a way to talk to JavaScript on the host. And by talking to JavaScript on the host, then you gain access to the HTML canvas and so on. Oh, right, there you go, WebGL.
Okay, thanks, Stephanie. Awesome, thank you.
I would actually like to add, like, especially for games, right? Like most of the compute that happens in games, and I'm not a game developer, but I think most of it is really just number crunching. Like it's a lot of compute, like for shader rendering, like not specifically the rendering, but like the compute that has to happen to render these scenes and whatnot. You can still, like on a very low level, that's all just like number crunching, right? And you can still have WebAssembly do that bulk of work and do that very efficiently. And then the rendering happens somewhere else where you could, like some U8 slice or some like, array of numbers is being passed back to the host, which then just takes that and then it's being rendered onto a screen. But the compute and calculations, all of that can still, happen inside that WebAssembly module.
Okay, awesome. So I have a question about. I read a counter argument against WebAssembly in the browser in particular, based on the fact that loading the WebAssembly modules initially can be a lengthy process, whereas with JavaScript, you've got a bunch of optimizations, just-in-time compilation, tree shaking. I don't even know everything that goes on there. That means that you can have a lot of JavaScript and a lot of JavaScript files and still control like the timing of when you bring things into play, whereas with WebAssembly you kind of have to like front load everything.
That actually seems, so I don't know exactly what scenario that counter argument was referring to, but one of the things that I really like about WebAssembly is that it's a streamable binary format. What's interesting about the layout of the WebAssembly virtual machine, which in my limited experience is unique. I haven't seen any others that work like this, but you can start at the first instruction in the file and be guaranteed that you don't need any other information from the rest of the file yet in order to process it. So you can start processing the instructions from a WebAssembly file before the browser has received the end of the file. And so when you instantiate a WebAssembly module in streaming mode, you're quite literally just working off of the first byte in that file while you're still streaming the rest of it. And so in that fashion, it's significantly faster than trying to compile an entire JavaScript function.
Interesting. It actually sounds like it was made for HTTP2. Okay.
I like to add there as well is that so in front-end applications, a lot of like to reduce the size of the app, people started using lazy loading, where actually based on a route in your application or navigation action, you load another JavaScript file in. You have to wait for it because the browser has to parse it, has to like execute the JavaScript, and then actually something happens on your screen. With WebAssembly, you can like also lazy load the WASM itself, like when you need it. But like Kevin pointed out, is that WebAssembly allows you to instantiate a stream of data, so you can actually already start downloading the WebAssembly file and then like already instantiate that stream of data that's coming in. So.
And is it typical in a, let's stick with a front-end application, like a web application as an example, is it typical to have a number of WASM files then that each have a specific purpose? Can I think of it as like my functions or subroutines, or like my microservice architecture within the browser? Is it like libraries that I load? How do you guys structure that at StackBlitz?
Yeah, I guess I can speak to that. So for StackBlitz, there's currently well, there's a couple of like binaries. Well, actually not a couple. There's basically two binaries compiled from Rust to WebAssembly. One is a file system completely written in Rust, which is highly scalable, lazy loadable, fully multi-threaded, and that's, as I said, written in Rust and compiled to WebAssembly. And then we have another layer, which is the crypto layer. And so to answer your question, yeah, you can structure this in any way you want. You could have one binary which contains like multiple services, for instance, or you could split them and have like every service, if you want to call it like that, be separated into its own binary.
Okay.
I mean, the benefit is something that Sam pointed out, is you could lazy load them like on demand, and that's what we do, or at least is something you could do. Like if you only need this service, if someone calls this function, for instance, then you could lazy load it, or you could stream it in the background as the application is being executed. There's many ways. I guess it really depends on the application you're building.
We're actually using another WASM as well, which we didn't wrote ourselves, but it's for actually our IDE. So if we go back to who used WASM before, VS Code actually uses WASM under the hood. for parsing their TextMate files, which is for like
VS Code, the IDE editor that everybody
uses. The IDE. Yeah, exactly. So they use WASM, and they use for the TextMate files. So for all the nice color coding of your code, TextMate uses Oniguruma. I don't know if I pronounce it right, but and VS Code actually compiled that to WASM. So you can find it on GitHub, VS Code Oniguruma WASM. And that's also what we use to actually color code or like use for TextMate parsing.
But I don't understand why they would compile it to WASM instead of just using a binary. Is it the cross is it like compile run once, run everywhere mentality?
A lot of the motivation.
Compile it to every platform.
Yeah, a lot of the motivation there is that if you can compile it to WebAssembly, then there's no additional work required to make it portable. Once it's in WASM format, it'll run anywhere.
Does anybody ship a WASM command line tool? Is such a thing?
Several people do, actually. There's a couple of different WebAssembly runtimes that ship a WASM command line tool that runs WebAssembly, that runs arbitrary WebAssembly modules.
Okay, so I need two things. I need the WebAssembly runner and then the WebAssembly module itself. So if I'd have to package those two together and maybe still compile it to specific platforms if I want to. So it's not an improvement on writing CLIs.
No, I don't think so.
Okay, I was just fishing. I would like to back up and come back to StackBlitz. I think it's time to explain to the world, by the world, I mean the people listening right now, what you guys do. What's your product? What's the big picture there?
Do you want me to take that? Okay. So StackBlitz actually develops an IDE or a web browser-based IDE, let's say, which you can like compare with Visual Studio Code. Visual Studio Code, of course, has a lot more features, but so people can actually just open their web browser. If they want to start programming, they can go to stackblitz.com and they can like choose a preset that we gave them. Like if they want to start with Node.js, for instance, they can click on the Node.js preset, and then they basically get like an environment that you would typically see on local. So you get a terminal that you can use. You get like a code editor, which is based on Visual Studio Code, and you can then start developing what you want. You can create an HTTP server. You can start with Angular. You can start with Vue. You can start with Svelte without actually having to install anything locally. So it's very nice for like programmers who are people who want to start programming, or also let's say you own a Chromebook, you want to start developing on Chromebook. It's like the newer Chromebooks have like this thing where you can actually boot Linux, I think, or you have a terminal and you can do stuff, but older ones or cheaper ones don't. So you only basically get a browser, and then you can also start developing things in your browser, basically.
Where would my files be stored in that case?
Good question. So there are multiple options. One, the default one is that your files are stored, like you can sign in with GitHub. Files are stored on the StackBlitz servers. And then basically you can just refresh your browser, you still have your files. Or you can also work with your local file system. So you can basically open through the browser APIs, open a local directory, and then all the files that you create in that directory get synced to your local file system.
Okay, sounds pretty amazing. So what part of that is the WASM? And I'm guessing it's the part where you said you could start with Angular, or Svelte, or whatever you wanted. Because when I read your blog about running Node in web containers, one of the bragging points that you brought up was optimizations to NPM, and that, like everybody who's done anything with NPM or Yarn knows that if you're doing a really serious JavaScript application, you basically wait until it's downloaded the entire world before you're done. It's like it's like npm install is the new compile, right? It's like you used to like compile your code and go, the XKCD cartoon about that. And now it's npm install. So you guys said it's a lot faster when doing that in your web containers. So do I have it right? Do you have the web containers there so that people have the right environment to do their coding inside of?
Yeah, that's correct. Maybe to give a little bit more background, like StackBlitz has been around for a couple of years, and it's been founded by Eric Simmons and Albert Pai in the beginning. And so they developed StackBlitz, the online editor, and for quite some time it's been only being used for like front-end projects. So you couldn't really run anything that would normally run on a server or your native system. And so then we've actually been working on this technology, web container, for quite some time. Actually, it's been almost 2 years since the first commit. And so a lot of work has went into this new technology, which is an application runtime that lets you run entire Node programs inside the browser without running anything on any remote servers. So it's very innovative in a sense because it doesn't require any remote compute. And StackBlitz, like the core philosophy of StackBlitz is to really leverage the user's compute as much as we can, like to run as little on a server.
You're putting a small little cloud in my browser.
Yeah, it's like, I mean, it's a little like a small operating system, except it's not a full-fledged operating system, but at least in a sense, because it allows you to run Node.js in a browser, and you can launch servers without ever running them on a remote server.
So the cloud, no longer somebody else's computer.
Yeah, exactly. I mean, there's no servers running, so our cost is actually pretty low for that, because we just use the compute the users already have. They have a machine, and most developers in most companies, they have machines, and it doesn't have to be a beast. It doesn't require like really good high-end machines. It actually also runs on like lower-end devices pretty well, because Web Container has been optimized for these use cases. And we know that not everyone has super fast internet connections, and so we really try to optimize also for these, for those use cases where people have not high-end machines or have slower internet connections and these kind of things.
Okay, so fascinating. You've got a web IDE that allows you to deploy the code that you're writing into a Node.js container running in the browser. Fascinating. Sounds really cool. Very innovative, like you said. I'd like to ask about WASM Cloud. Kevin, could you describe what WASM Cloud is and what you're doing with that?
Okay. So WASM Cloud is taking WebAssembly and leveraging the portability of it and the size and the security, and using it for not just cloud development, but edge and everywhere in between. The idea is that if you can write your business logic as actors that, for the actor model that compile to WebAssembly modules, then you can take those modules and deploy them on cloud servers anywhere, and we link them up with capability providers. So like I mentioned earlier, that WebAssembly modules have no powers, no capabilities that aren't granted to them by the host. And so the WASM Cloud host runtime grants these WebAssembly modules secure access to things like database servers and HTTP clients and web servers and any other cloud capabilities they need, Blob Store or things like that. So what we do is we're trying to take all the boilerplate, the non-functional requirements out of building microservices and or monoliths, and we strip out all that boilerplate and get right down to building the pure business logic. And then once you have this pure business logic distilled down into a single WebAssembly module, you can run it anywhere. You can run it in a browser, you can run it on a server, you can run it on a Raspberry Pi. And what WASM Cloud lets you do is let that compute free flow within a network, as well as the capabilities that it consumes. You're on mute.
Oh yeah, as the show host, I should know that already. So what the WASM Cloud lets you do is actually aggregate all of these potential compute environments and pass these actors around, and the actors are then enabled by capability providers, which is probably context specific. Help me understand that model a little bit better, and maybe also go a little bit into the statement that if you can express your business logic in the actor model. That says nothing to me since I haven't studied the actor model. What do you mean?
So by actor model, it's just a generic computer science concept, but when we're describing actors, what essentially that means is you have an isolated piece of compute that reacts to stimulus from its environment. So it receives messages. So all of the coding that you do in an actor is either receiving messages or sending messages to somewhere else. And in this case, that's either to other actors or to a capability provider. So, if you were to try and build a microservice today that, you talk to over a RESTful interface, and it then were to talk to a database. If you were to do that now using today's regular technology, you would be responsible for writing the code that starts up the web server. You'd be responsible for writing the code that communicates to a very specific type of database. And all of that is tightly coupled and full of boilerplate and non-portable. That stuff only works where you've coded it to work. But if instead you were to create an actor using WASM Cloud, for instance, your actor is written to an abstraction over the fact that it receives messages from a web server, but it doesn't dictate which one, and it communicates with a database, but doesn't dictate which one. And so when you deploy your actor at runtime, you get to choose which database it connects to and how it gets its web connections. And at runtime, you can actually swap the implementation of those capability providers. So you could switch from using Redis to using Cassandra live at runtime without having to redeploy your actor.
That sounds horrifying.
Well, I mean, there may be
I'm sure there's a use case,
but want to do that, but I mean, certainly wouldn't want to do that that specific scenario live at runtime. But one of the things that I've experienced, having spent years and years building microservices and doing back-end application development, is we spend probably around 90% of our time writing code that's in service of non-functional requirements and in boilerplate, and only about 10% of it is real business logic.
Yeah, I understand that, because at Platform.sh, part of the value that we offer our customers is automating all of those connections through relationships that are a detail of the environment that the application runs in, rather than code that you have to string together yourself. So that's part of, I totally understand that. And I do acknowledge that, switching Redis and Cassandra might actually be a real use case, but it still sounds horrifying.
Yeah. So, our WASM Cloud's proposition is that if you want to write pure business logic in WebAssembly, then there are a number of advantages that you get in terms of both portability and security. So one thing that we do is we embed cryptographic signatures inside the WebAssembly modules, so that what that module is capable of doing, what it's allowed to do, that policy actually follows the module, not the environment.
Just chatting with Sam. The observant viewer saw that he had a visitor, which was quite cute. Okay, so it sounds to me actually like if I'm a developer and I'm like writing code that can run in a WASM container and StackBlitz, that it would be a perfectly native extension to my expectation to be able to deploy it onto the WASM Cloud. Is there some truth to that?
Well, probably not. I mean, in order to build a WASM Cloud actor that talks to capability providers, your WebAssembly module needs to conform to a specific set of standards. But as long as your WebAssembly module exposes certain functions and expects to import certain functions, then it would be compatible with WASM Cloud. I don't know what it would take to be compatible with StackBlitz stuff.
Okay. Again, I'm fishing. Let's back up to a different angle of this. So assuming there are people watching the episode who are curious about WebAssembly and who haven't yet started, how do I get started with this? What's a good entry point for me as a programmer? What's my hello world look like? And where do I go to do that and find that? And should I learn Rust?
So I'm biased, and I would say yes, you should learn Rust. The Rust probably has the best ecosystem of tooling and support for WebAssembly right now. But the easiest way, I think, to get into writing code that compiles to WebAssembly might be through AssemblyScript. AssemblyScript, if you're not familiar with it, is essentially a subset of TypeScript that compiles directly into WebAssembly. So it's a pretty approachable way to start writing WebAssembly modules. And one of the really interesting things I've seen is the AssemblyScript compiler itself has been compiled into WebAssembly. So you can host a WebAssembly or an AssemblyScript compiler inside a browser page, so that you can write and compile AssemblyScript live inside the browser. And I think there's actually a couple of playgrounds that let you do just that, where you can just open a browser, start typing your AssemblyScript code, and get a WebAssembly module out of it.
Amazing.
That's technically something you could do. That's actually a really good point you brought up, Kevin, is that compiler has been compiled to WebAssembly. So in theory, you can just use that on StackBlitz as well, because you can just load it into StackBlitz, write your assembly script, compile it to WebAssembly, and then execute it even inside StackBlitz.
So go to StackBlitz is the answer.
I mean, well, for AssemblyScript, that might be true, or at least that's something you could try. But
the audience is agreeing.
Yeah.
But for other languages, that it's not that easy, because you can't write Rust code in a browser, because the compiler doesn't run in a browser, so you can't write Rust and then compile it to WebAssembly inside a browser. Hopefully that will be possible at some point. Also for other languages, that would be very cool. But yeah.
So AssemblyScript is what you called that.
Yes.
Amazing. Okay. And if I'm a web developer and I'm happily going along my way doing JavaScript and TypeScript type things, at what point am I going to be forced to learn this technology? Am I on a collision course with this? Is fate pushing me towards it? Is the world adopting it that fast that I'm going to have to uptool to understand WebAssembly, or can I avoid it altogether?
I think the ultimate goal is for people to avoid it altogether, and that WebAssembly is just so seamlessly integrated into all the various tool chains that you're unaware of the fact that it's there. It's like, so Docker isn't, it isn't the end game or the end goal. Docker is, if you're using Docker well, then you're generally not all that, you don't have to be exposed to the inner plumbing of how Docker works. And I'd like to see WebAssembly get to someplace similar where it's a compile target today, and but in order to interact with it, there's an awful lot of ceremony that we have to deal with today, just because it's a fairly immature ecosystem. But fairly soon we should be in a world where WebAssembly could be everywhere pervasively, and we just don't have to think about it.
And is part of that world the WASM Cloud?
I hope so.
I hope so for you too as well, and it sounds like it would be also good for the compute environment. I heard a rumor that the Ethereum blockchain was looking at WASM as well for smart contracts. Do you guys know anything about that?
There's actually quite a few different aspects of the blockchain that are involved in WebAssembly. I think a number of the Rust, the really early Rust WebAssembly libraries for interpreting and executing WebAssembly all came out of various forms of blockchain.
Okay, so should I be learning this to write my smart contracts in the future?
Well, again, hopefully you're not using WebAssembly as a language, and it's more a means to an end. So you can write smart contracts in assembly script. I think there's a couple of places, a couple of things that support that, but ideally you should be able to write smart contracts in any language that can target WebAssembly, and you wouldn't have to worry about the fact that WebAssembly is your means to an end there.
I think that goes back to the comment that somebody made that it's more like an operating system.
Mm.
Yeah. Okay, that makes sense.
It's
So,
also, I mean,
yep.
I just want to add, like, a really good friend of mine, Christoph Burgdorf, is actually working on the Ethereum Foundation, and by the way, I'm not an expert when it comes to that topic, but I think he works on like a smart contract language which is written entirely in Rust, and I think it's called FE. I think if you search for Ethereum FE, then you can find that. And one of the things is that first of all, it's written in Rust, and I think it can also be compiled into WASM, which basically gives you the portability and ability to run it in a browser. I think to write like smart contracts. But again, I'm not the right person to get into details here.
Okay, cool. Thank you. And I've got the project there up on the screen. So, Kevin, you've mentioned several times that the ecosystem is very immature, but it sounds like it's evolving quickly. What kinds of things should we be looking forward to as the ecosystem evolves? What are some of the projects that are already on the horizon, or the stuff that dreams are made of?
Well, I think some of the stuff that's supposed to be coming fairly soon are advances in the WebAssembly spec or the WebAssembly standard itself. So I mentioned WASI before, the WebAssembly System Interface. Right now, that standard doesn't have a good answer for making network calls, but that should be taken care of hopefully fairly soon. So there will be a standard secure way of giving WebAssembly modules access to the network, so that when you compile your networking code that just uses regular TCP sockets, there'll be something in your language compiler that'll know how to convert that from your language into that WebAssembly standard. And so compiling network code to WebAssembly should be seamless, and people are aware of all the heavy lifting that goes on underneath.
Can I pause there? Dominic, does that mean that I could use your web containers to run a Node.js-based website from my browser?
Yeah. Wait,
crazy.
yeah. I mean, I guess.
Run a website from within my browser.
What do you mean by running a website?
Well, have a little dynamic DNS going on, and publish it out there, and have incoming requests hit a node container that's running in my browser.
You mean like incoming requests from like outside the browser from somewhere else?
Yeah.
Is it? No. So okay. Okay, so yeah, now I get it. No, so unfortunately, this is not possible. So right now on StackBlitz, you run the server inside the browser, but that basically limits the requests to only come from within the same domain, like the same tab.
Is
like,
that just because of cores, or because of limitations?
No, because
there, or what are the limitations?
No, because it's just like the way this technology works. It's something we call local service. So we basically map the server API to this to a service worker API, and they're more or less. I mean, there's ways you can make, for instance, or you could make requests from another page, from another tab in another domain to that server, which is running on another domain, but it's currently not supported. And getting incoming requests from a completely different machine somewhere else in the world, that's a little bit more tricky, because the browser doesn't really allow you to open sockets.
So the
there is no
sandbox is the problem there. Okay.
Yeah, I mean, browsers have been optimized for speed and security. And it's the nature of this secure sandbox, which is a good thing, but it can also be a bad thing, because there's several things we cannot do. But I think the browser is being improved, and there's more APIs added to the browser. And I think one cool project I'd like to mention is the project Fugu, which is like a Google project, which is a project for web capabilities, and they add like various new APIs to the browser, and they work on that. And one of those new APIs is, for instance, the Chrome FS API, which we also use on StackBlitz, for instance, if you want to connect it to a local directory which you have on your system. And I think this is really cool. Yeah. And I'm very, very excited about this project in general, because they're doing their best to make the browser even more capable, and adding more APIs to it. And hopefully at some point we have the ability to even open sockets. I think there is even a proposal for that, if I'm not mistaken. But yeah, I mean, it's going to take a while, but hopefully we get there.
Cool. Kevin, I think you had something to add.
Yeah, one of the things that we've done in prototype form is starting a WASM Cloud host inside a browser, and then using WebSockets over NATs. NAT's the product, not NAT, the network protocol. But so using WebSockets from the WASM Cloud host running in the browser to essentially attach that browser tab to your network of other cloud-hosted actors and capabilities. So while you can't necessarily have a web server running in the browser, what you can have is compute running in the browser in a browser tab that's answering web requests that were received from a web server running elsewhere in the cloud.
That's cool. Especially if I'm sitting there in my StackBlitz terminal writing that code in real time. Swapping it out. Not really. I wouldn't ever do that. I have one more question, and it's going to make us go a little bit over time. I read that threaded WASM is something that's coming up in the future. Is that true, and why is that important? Am I wrong?
Should I take a stab at it? I mean, I can.
If you can.
Kevin, you wanna
Go ahead.
I think I don't know what the exact status of it is. I know there are proposals for threads inside WebAssembly. For me personally, it's one of those questions of, it's not a question of whether we can, it's a question of whether we should. Having threads inside, giving the ability for a WebAssembly module to create a new thread of its own, on its own now means that developers have to be worried about async programming inside their WebAssembly module. Today, it's nice because inside the WebAssembly module, everything is single-threaded, so there is no async programming inside there. And async programming is hard and error-prone, and all of us do it wrong more than half the time. So anytime you introduce async programming, it's, I think things are going to get more error-prone. So I personally want to see WebAssembly stay single-threaded on the inside and find ways for improving efficiency on the outside in the runtime. But I know there are a bunch of use cases where giving modules access to multiple threads makes a lot of sense. So, but I don't know what the status is of the standardization of that. I know it's currently not baked into any of the runtimes that we've got.
Good, thank you. Well, we are at the top of the hour, a little bit beyond even. I love this topic. I think it's really exciting. It changes the way that I think about the capabilities of the web and beyond the web, as Kevin's pointed out. So it's certainly a topic to be watched. Thank you all for being my guests. Thank you all out in the audience for paying attention, interacting with us, asking your questions, looking stuff up in the background. It was really great to have you. And come back next week for another episode of Deploy Friday. I will be on vacation. Your host will be Chad Carlson. But it's going to be great. So tune in then. And goodbye. Have a great weekend.
Thanks for having us.
Yeah, thanks for having me.
Thanks for having us.